Good morning, dear friends. From this video lecture onwards, let us discuss about some of the basic fundamentals in aerodynamics and so some of the important concepts in aerodynamics. So first, in this video lecture, let us discuss about the quarter chord point, particularly the movement about the quarter chord point, and also movement about the leading edge. So let us discuss about both the points. And we all know that when the aerofoil is suspended in airfield or airflow, then what happens? It is subjected to both the pressure force and skin friction force. So we can say that this is pressure force. This is the pressure force, and this is the skin friction force. This skin friction force, we all know that is that is responsible for creating the drag. Also, not only by the skin friction, also there is a drag due to the pressure. So this is actually a skin friction drag, skin friction component, and pressure acting. Okay, if the pressure is acting outward, that means away from the surface, generally taken as the negative. So we can say this is negative, and pressure acting towards the surface. So generally towards the surface, taken as the positive. So this is pressure is positive and this pressure is negative. So generally the skin friction or shear stress will be acting tangential in the tangential direction on the surface. So because of these forces, what happened? There will be a because of these two forces, there will be a movement, or we can say if you choose any point on the aerofoil, then with respect to that point, the moment will be created. So that is what first thing we need to understand. So if the moment is created because of this pressure force and shear stress component, then with respect to the quarter chord point and also with respect to the leading edge, how it is varying. So that is we have to discuss. So with respect to the quarter chord point, so we just if you want, we can calculate, because here the moment will be acting. That means moment will be generated because of the forces. That forces will be acting somewhere on the on the aerofoil. That force point we can call it as center of pressure. Center of pressure, that later on we'll discuss in detail what is meant by center of pressure. So center of pressure, nothing but it is the center position of the pressure distribution. So generally we can call it as center of pressure as equivalent that of centroid in other objects. So we know how to find out the centroid for any given object. So similarly for the aerofoil, we have the centroid, that is nothing but center of pressure, where the resultant forces will be acting. So center of pressure is the point where the resultant forces will be acting, and there will not be any movement. Movement will be zero at that point. So this movement and this moment both are created due to the forces, that means resultant forces acting at the center of pressure. So that is what we can say now. So because of these two forces, so this moment is created, and also this moment about the quarter chord point, moment about the leading edge. If moment about the quarter chord point is something, so that means if you know the resultant force, suppose if you say the resultant force is somewhere, it is, so we can just say that resultant force. So this is the resultant force. Due to this resultant force, we will be having two components. That means one will be the vertical and one will be horizontal. So this resultant forces are giving another two components, so that we can call it as this. One is horizontal, another one is vertical. So this component only we call it as lift and drag. So okay, so if the with respect to this component, then what is the movement at this point? So that is what we need to calculate. And similarly here also, because here also the resultant forces will be acting here. So resultant forces are acting here. So these resultant forces are subjected to both vertical and horizontal component. So resultant component we can say this lift and drag. So if these two components will be generating the pitching moment, that means moment about the leading edge. Here also that means these two components will be generating the moment about the pitch, quarter chord point. So generally vertical component into horizontal distance. So the vertical force into horizontal distance will give the moment. So that is what so basic concept, basic theory says. And suppose if this point is arbitrary point somewhere on the aerofoil, somewhere on the chord of the aerofoil, then this moment also will be varying. So that is what this says, because the quarter chord point we have fixed. So 1/4 of the distance, 1/4 of the chord length. So that point we have fixed at this position. So it can be anything. It is not like just we have selected. So it can be at any point. It may be a 30% or 40% or this. But quarter chord point, why do we choose a quarter chord point? Quarter chord point has the some of the importance. That means one of the importance, that is nothing but if the quarter chord point at the quarter chord point only, both the aerodynamic center and the center of pressure coincides. As per the thin aerofoil theory, so in flat plate both the aerodynamic center and the center of pressure are okay. So that means coincide, and that point we call it as quarter chord point. So even in for the symmetrical aerofoil, so this both aerodynamic center and center of pressure, that will be coinciding. So that is why for thin aerofoil, that means if the aerofoil is subjected to very thin, and in that case if the aerofoil is symmetrical, so in that case then we can call it as both, that means both the aerodynamic center and the center of pressure are at the same place. So that is one of the thing. So that is that has some significance. So even with respect to the stability perspective, so those things we will discuss at the later section. Now let us see how the lift is creating the movement about the aerodynamic center, that means movement about the this quarter chord point. So movement about the quarter chord point, nothing but this is movement about the quarter chord point. We say this, it is equal to lift into this horizontal distance. Suppose if this point is nothing but we can say center of pressure, so the center of pressure, then this point if you take it as, we can just say that this is the point XCP. So then movement about this point is nothing but this distance minus this distance. So we can say that XCP minus 0 point, that means 0.25 this. So we can just into multiplied by this vertical component of the resultant force, nothing but lift. So this. So this is what. So generally this will be clockwise movement will be taken as positive, because the clockwise movement generally is subjected to increase the angle of attack. So that we generally take it as positive. Then anti-clockwise generally taken as negative. So clockwise movement generally produces nose up movement. So here it is, this movement is subjected to produce the nose up movement or positive movement, we can say. But generally in the aerofoil theory, as per the aerodynamics or aircraft theory, then moment will be negative. That means pitch down moment will be a pitch down moment. So that means that will decrease the angle of attack. So that is the concept we are just following in aerodynamics, aircraft aerodynamics. First, this clockwise. Why it is positive? Because of the clockwise this. Because this will be creating. If you are taking the forces, then the forces will be creating the clockwise. Just we are taking as clockwise movement as positive, and this force it will be creating because we can say this is upward into this point. So with respect to this, so that will be creating nose down. So because if you say that lift is acting upward, then the movement will be anti-clockwise. That means negative movement. So positive movement we have taken the clockwise movement to indicate the movement is positive. So that is only the idea. So here also the movement, that means movement about leading edge. Movement about leading edge will be this is okay with respect to this point, nothing but XCP. That means position of the center of pressure. So this is we can say that XCP into L. So this is what the moment here. So here the moment will be here in this case. If you see the magnitude, magnitude wise moment will be smaller here, and magnitude wise moment will be larger. So that is what we have to understand. So because when we are fixing the axis, about this point, so if if you are fixing this point, then that is perpendicular to the page, perpendicular to this figure. So suppose if you are fixing it, then what will happen? That will be creating the moment when it is when the aerofoil is subjected to or when if the aerofoil is suspended in the airflow. So that is what we have to understand. So in this case, that means here we say the for the nose down, the lift will be negative. So that means here also we can say for the positive case the movement is positive. For the negative case, that means negative case the movement will be negative. That means for the pitch down case, then movement will be negative. So this is pitch down. We can say it is pitch down. And here we can say it is nose up condition, or we can say pitch up moment. So that is the difference. So that means as per the convention we are taking clockwise as positive and anti-clockwise as negative. So here also that means this negative indicates it is an anti-clockwise. That means because upward force into horizontal force, generally because this will be the convention, because the lift is going up, then it will be creating with respect to this point, then this will be creating a negative movement. So we can say that this movement will be negative. So that's what, even with respect to the any magnitude, suppose if the lift is equal to, suppose if the lift is 200 Newton, here also if the lift is 200 Newton, then we can calculate what will be the magnitude of this. If the lift is 200 and that is acting 30% of the 30% of the chord, okay, chord in center of pressure. So that means center of pressure is okay located at 30% of the chord. So that is what we have to understand. So if you say that lift is acting at the 30% of the chord, then this value will be we can say 0.3 C minus, with respect to the quarter chord point, what is the moment, then this is 0.25 then into L. So we can calculate this will be equal to 0.005 into L. that means 200. So if you say, so 200 into 5, so that will be equal to 10 Newton meter. So similarly here also we can calculate the moment for the moment about the leading edge. So that will be nothing but this is 0.3. So 0.3 percentage of C. Okay, that means center of pressure is located at 30% of the chord. So here we can say that this will be equal to minus 0.3 into 200. So the moment is value is here it is that is nothing but 18. So 200 into 3 60. Yeah, it is nothing but 60 Newton per meter. So for the same magnitude of the lift, so the vertical component, so for the quarter, about the quarter chord point we are getting 10 Newton per meter, 10 Newton meter, and about the leading edge we are getting 16 Newton meter. So that means, so moment about the leading edge is minus 60, and moment about the quarter chord point is minus 10. So that from this we can understand one thing, that moment is larger with respect to the leading edge, and the same moment, that means the twisting moment, twisting moment is lesser at the quarter chord point. So that is also one of the reason, because at the quarter chord point only we say both the center of pressure and aerodynamic center coincides as per the thin aerofoil theory, and especially for the flat plate. And also this is true for the symmetrical aerofoil, symmetrical thin aerofoil. So for that case also center of pressure and the aerodynamic center will be coinciding.